get, post, or whatever, just doesn't come back with a response, or any other thing happens. Request gets dropped. What should you do? Should you fail the whole program because a network request was wrong? I don't think so, especially if it's a GET request. So what we really want to do is we want to retry on those errors. We would like to retry only on those. It's not very productive to retry if something unexpected went out, as I said before. But it's hard. And to be honest, after a few attempts, I found absolutely no way of putting that in the slides. So I opted out for, well, not kind of retrying on every error. And is it a normal retry? Is it fine to retry constantly? Well, not really. Is it fine to retry every 10 milliseconds? Well, depends. The best practices in the industry are to retry with some sort of exponential growth curve, such that you start retrying very fast at the beginning, and if you still see that your program doesn't work, that the requests keep failing, the worst thing you can do is keep retrying as fast as possible. Because if you have a service with degraded performance, you're gonna kill it. You're gonna bring it down. The best thing you should do is start to retry fast, but slow down the retry as you go. But would you really want an unbounded time? Does it really make sense for our program to wait for 10 days? Maybe in some cases, yes, but probably most of what we build doesn't have that type of, we should get back to the user a response fast enough. 10 days, that's a little bit too much. So what's the deal? Gotta put some cap at the maximum and gonna put a limit of retries. And if you see, anything here gets inside the same option parameter. You could use multiple parameters. You could write this function in any style you want. But the point is, all of that needs to be coupled. I have one policy which knows what my retry strategy. It's not specialized based on the error. And me wanting to organize code a little bit better, at least I extracted the retry logic out. But again, if I extract the logic out, I have no longer the ability of specializing what happens based on the error. Now, the slides are small. And I want at least the people in front of me to read the code. So I sort of stopped here and sort of listed some other things that you might encounter. I want to be clear about that. Not all of those things are strictly required. And not all of those things you will know at the first day. Your program has to evolve over time, especially if it works, especially if it touches production, and especially if it grows. So what's left? Well, logging, gotta log, gotta make some distinguishment between logging an error, logging an information, logging a debug message. Namely, the logging should be multi-level. And also, you've got cases where you have an app that fails, and no logs are shown at all. That may be because the problem happened in a portion of the program where you need to escalate the log level locally to say, okay, on this section of the program, I actually want to turn off the bug logging to see everything, and turn all to a different log level such that the rest of the application stays silent, but one part speaks. You might have guessed would have required a little bit more space than a slide. Then we gotta do metrics, because we gotta wanna know how many requests we are doing per second. We gonna wanna know what the average degradation of the service. We wanna know gauges and any type of metric. And how do you really integrate metrics? Well, you gotta hook around with libraries linking to Prometheus and or OpenTelemetry that nowadays supports both tracing and metrics. But still, there's a lot of specialized code that you have to do to integrate those services. Tracing is the next one. Tracing in the sense of isolated parts of your program should define spans that are well named, and within the spans you can attach attributes, and some of those attributes might be this portion of the program failed for this reason with this stack trace. And all of that appears on an online console where everything starts to make sense. And also tracing is very important if you're trying to optimize an app at scale. Because if you don't observe what's going on inside the app, you're not gonna have many ways of saying what's slow, what's fast, what's optimizable, what's not. Propagating span context is definitely not an easy thing. You could pass it explicitly by function arguments. More recently, you could use an approximation of thread local that ended up in stage 2, which is the async context, to keep the spans around. But still, one thing I've told you, in a span, if the process fails, if that span is failed, the error should be reported. What does it mean? It means literally you have to wrap pretty much all your code, every single piece of your code that you want to identify inside a span, inside a try-catch. And in case you catch an exception, render the exception on the span, and throw again. And maybe you need a little bit of testability at some point. And really, testability is about being able to inject dependencies, being able to inject mocked services, being able to inject test dummies and stuff like that. And you have various ways to do that. You have inversion of control containers, again, explicit passing of function argument, and so on and so forth. Could follow cake pattern and all of that. But still, if you want to achieve testability, and at some point in time you might, that's one thing you have to care about. And et cetera, et cetera, et cetera. There's so many things. And does any of you believe that the code I've shown before is actually maintainable? Would you be able to change that code confidently, being sure that nothing goes completely off, that you don't break it? No? No one confident enough to say, yeah, I can? I am not the only one. I thought I was the worst programmer in the world. So again, that's the short story of my life. Trying to build those systems, trying to scale those systems, trying to manage teams across code bases of hundreds of thousands of lines of code, and seeing those patterns over and over again. So 2.5 years ago, actually a little bit more, I've kind of set a personal goal. I wanted a composable set of solutions. One of the main problems of all of the solutions that I've shown before is the fundamental lack of composability. If you remember, I was mentioning in the retry policy that we wrote, we had to couple together all of the options that defined the behavior of the policy. The try-catch around every span and et cetera, is specialized code. Anything we've seen to this point was adding progressively to the code we had in a non-composable way. In a way where extracting a piece of logic to be shared between two different places of your program is a fundamentally hard thing. It's not impossible. You can do composability on your own. You can build composable APIs on your code. takes time and might be counterintuitive. So, welcome to Effect. We are going to redo the same thing with Effect, and hopefully, if time allows, we are going to do a bit more than what we've seen. I'm not going to go into too much details of what Effect is. Nobody really cares about it. Not even I do. To me, the simplest description that I could give, it's like a lazy promise. If I give you back, if I do fetch, I get back a promise, okay? The network operation already started. The promise represents only the result of that HTTP request. It doesn't represent the HTTP request itself. All of the information that promise was generated from an HTTP request is lost. With Effect, it's not like that. If I return an effect, no operations have started. That's a simple description of your code. It describes your intention. Only when you evaluate that effect into a fiber, then the actual effects run. What does that allow? Higher order behavior and composability. Because given an effect, I don't have something that already happened. I can say, redo this effect, reevaluate 10 times. Reevaluate as long as it fails, and so on and so forth. So let's start to see how does it look. First, I am going to identify the failure scenarios. Not all of them, because still has to fit the slides, but at least some. Here, we are identifying a fetch error, and our request function, which is a simple wrapper around fetch, as you see, it says try catch promise. Forces me to specify what the hell should I do in case this fails. And we're not going to do that much here, but we're going to flag that this error comes from a fetch error. And then the JSON body deserialization can also fail. But it can fail for a JSON body error. And by the way, I don't know if you've noticed, first I have type check slides, but look at this, it's here. When you call this, you know the reasons it could fail for. They're apparent. There's no need of further documentation in saying this might fail for reason A or B. When you have to deal with the result of this, you know it can fail for a fetch error. And the same thing goes on for the JSON body. Using Effect is a fairly large system. I'm going to list the modules after, but this is going to be a very short introduction. One common pattern that I've seen in code is to kind of reorganize your imports, both from your internal modules and re-exporting stuff that may come from Effect or from other libraries into kind of a common module or a set of common modules that you use across your code. I'm going to do that here for the purpose of fitting stuff in slides, because otherwise I spend too much on the import side. So using the fetch wrapper that we created before. Pipe might look unfamiliar to you, and it's fine. It's simply function application. This is exactly equivalent of taking this first argument and put it as a further argument in here, not as a further argument, but this function, the flat map function, ends up returning another function. That function takes the first as an input. This is just a simulation of kind of a fluent API call. What we know with promises and what we would really like to have, but unfortunately is very ineffective and not reshakable, is to do http.request.flatmap.blah. Etc. etc. So ignore everything, read it. HTTP request, flatmap, JSON body, which was the deserialization function. That's to add the get to-dos. We started with a sequential implementation. I'm going to start with a sequential implementation. We are using collect_all. Think of it like promise.all. And we're taking the IDs, type parameters. The first type parameter, which I said, gonna never. That's gonna be the list of requirements your program needs to run. So an effect is a program, is a description of a program that when evaluated requires this context. You should think of it like the React context might fail for this reason, continues.